Hello and welcome back. We're barely a week into October and my workshop is already 7 degrees in the mornings, which means either my foil insulation isn't as good as the solid insulation it quoted, or we've got some major drafts. I'm guessing it's a bit of both, although you can't really be surprised when you're working in a glorified shed. Right, so I've got a load of random bits of scaffold board left over from building some wraparound desks in our inside studio. There's probably around 8 to 10 metres of the stuff, but aside from a couple of big lengths, it's mainly just small offcuts. Almost all of the sections are either warped or cut to hell, and some of them still have the scaffold bands on, so I'm going to have to remove them first. I also don't have a thickness or a plane yet, which means I've got to face them all off on the CNC. It's not a hard job using a face tool path, but it's incredibly slow and tedious. I'm not too worried about the step over at this point with my 1/4" end mill. Flattish is going to be good enough at this point, as everything is going to be properly sanded afterwards anyway. I wanted to try carving a topographic map since before I had my CNC, so I'm going to give that a go. The location is going to be a section of Stanage Edge in the Peak District, which is where I proposed to my wife, so if all goes to plan, it might be something interesting for her to have on her desk at work. The main issue I think I'll run into is the choice of timber, to be honest. These were just labelled as softwood scaffold boards, and having looked into it, apparently the majority of UK boards are made of European whitewood, which is also known as common or Norway spruce. Honestly, I'm not entirely sure if they're spruce or pine. My knowledge of softwoods isn't that great. I'm much more familiar with hardwoods. But anyway, whatever softwood they are, they're likely to be really fibrous, which has caused me issues in the past when machining trays or anything that doesn't have a completely flat surface with vertical walls. For the first test, I'm using a 1/16 inch compression bit to rough out the sections with an adaptive pocket path. In hindsight, I should have used a larger end mill to get rid of the bulk of the material and then just used the 1/16 after. I didn't really know how this was going to go, so I was quite cautious with setting up the speeds and feeds. Progress was pretty slow with such a small end mill, but honestly the end results weren't terrible, so I was quite happy. Yeah, so something on the workbee that I've noticed that irritates me is you'll finish toolpath, send it back to the work zero, and then it will just be off by like 5mm. Even though nothing has changed, you can then home the machine, rework zero it, and it will end up in the right place. Luckily, I actually caught this on video for the first time. I really have no idea what's going on. What I'm doing now is just roughing a bit the outside out, and that's because for the parallel tool path, I've set the tool containment to be tool center on boundary, so I've just given it some room to avoid any collisions. So because I didn't really know what I was doing on this first parallel toolpath, I did multiple step downs, and the thing with that is like the entire first pass just missed everything. So I ended up pausing it and just lowering it to make it one continuous toolpath. The other issue I had is the step over was way too big, so it was creating these really noticeable gaps of kind of uncut material. So I had to reduce it by about, I think it was 60%. I was waiting on my ball end mill to arrive for these first two tests, so I ended up using my 20-degree V-bit for this first go. I know it's not exactly the right tool for the job, but I figured with a small enough step over it might be alright for a proof of concept. At the end it didn't look bad. Sadly, as expected, the fuzzies were a little bit crazy, and even with quite a good bit of cleaning and rough sanding, I couldn't make it look that much better. I decided to give it another go. I won't bore everyone with watching the initial adaptive pocket again, but for this test I used my 60-degree Amana V-bit. It's a lot less suitable than the 20-degree bit, but my thinking was maybe the Amana bit would create a lot less fuzzies, as it's just a much sharper tool. It didn't really make much of a difference overall. If anything, it was probably a bit worse. So now it's just time to wait for the ball end mill to arrive. This is also a quick comparison between the 20-degree and 60-degree V-bits. The one on the left is the 20-degree, and after a bit of rough sanding actually looked a hell of a lot better than the 60-degree, so I won't be trying that again. Right, my end mill has finally arrived. It's a 1/32 inch from Ooznest ball end mill. I've not used a ball end mill before, but I'm excited to see if it makes much of a difference. So this was all going quite well, but I ran into some sap deposits, I guess. I don't really know what the technical term is, which is a complete pain, but I just decided to carry on so I could test out the ball end mill and see what it'll look like at the end. This is my slightly janky setup for securing pieces down. I used double-sided tape, but it was ripping off when I was doing the final contour with big end mill. But with stuff like this, the smaller end mills I've got, they just don't reach far enough, and it ends up being a bit sketchy. So when it comes off the machine, I give it a decent sand. I go up to 240 grit normally, but actually on this I ended up using some 320 as well, just to kind of smooth out some of the imperfections. Then it's a case of mineral oil just to make the colours kind of pop, but I don't really like using stains. I haven't had a great track record with them in the past, with getting a really nice clean overall coat on something. So I thought this was a decent way of finishing it without having to worry too much. To finish it, I've got some little 3M sticky feet, which will just kind of keep off the ground. And then I am going to engrave a copper effect plaque on my laser, just with a little custom message on the back. This is a quick little comparison of them all next to each other. I think it is pretty obvious that 3 and 4 are much better than the rest of them. You can really see the difference in like the amount of fuzziness on the first two, although I'm not entirely happy with how much is still left on the final one, but I guess some more tweaking is needed. Right, that about wraps it all up really, so thank you for watching. What have we learned? Not a lot. It's always better to use the right tool for the job, but still a load of trial and error.